Hello. Yeah. Hello friends. Welcome to sakalvidya.com. So in today's session, we're going to discuss an important concept, that is Pascal's law. So guys, if you are new to this channel, please like, share and subscribe. Okay. So before having a discussion on Pascal's law, let us understand a small concept behind it. So for example, a river is flowing. For example, a river is flowing. So from this river, I took a small glass of water. I took a glass and I'm going to fill this glass with water. So remember students, river is under flowing condition. The water in the glass is under stationary, or static, or at rest. So the water inside the tumbler or a glass is static or rest or stationary. It's not going to move. Okay. So further I'm going to zoom this. As we know, water has n number of molecules. Water has n number of molecules. For example, I'm going to consider a small element here. I'm going to consider a small elementary section here. So this is a water molecule A. It is interlinked with other fluid molecules. Okay, right? So let area of this small elementary section be dA. Area be dA. Let capital A be the area of entire section, but dA represents area of the small elementary section. So this small elementary section, all remaining fluid particles are going to exert a pressure or force in normal to it. Normal is nothing but perpendicular to it, which means dF. So let dF is nothing but force applied by the surrounding fluid particles. Okay. So I'm going to take a ratio of dF by dA. So this dF by dA is called as intensity of pressure, or simply we call it as pressure. So my dear students, dP is equal to dF by dA. Change in force by change in area is nothing but intensity of pressure. This is very, very important. So in general, pressure capital P is equal to area of, or ratio of, force by area. So now what is the new formula for pressure? It is defined as ratio of force per area, or force acting per unit area. Now let us consider the units for it. One of the important unit, that is in MKS units. In MKS, what are the units for force? In general, we consider it as kg force by meter square, right? And also kgf divided by centimeter square. kgf is not a movie, my dear students, it is kilogram force. So 1 kgf is also called as 1 Newton. 1 kilogram force is also equal to 1 Newton. Okay. In similar fashion, if you consider the units in SI units, so we can write a units for pressure, that is Newton per meter square or Newton per mm square. Both are same, Newton per mm square. So for your kind information, Newton per meter square is also called as Pascal. Simply it is denoted as PA. So my dear students, 1 Newton per meter square is equal to 1 Pascal. 1 Newton per meter square is equal to 1 Pascal. Same like Newton, Pascal is also a scientist. In order to honor him, we have given the units on his name, right? Yes. So, my dear students, this is very, very important. 1 kilopascal is equal to, kilo means 1000, right? Kilo means 1000. 1, 2, 3 Newton per meter square. So 1 kilopascal, 1 kPa is nothing but 1 kPa is nothing but kilopascal. kPa is nothing but kilopascal. Same like your kilogram, kg, right? Okay. In similar fashion, this unit is very, very important. That is 1 bar is equal to 100 kPa. 1 bar is equal to 100 kPa. So what is 1 kPa? 1 kPa is equal to 1000 Newton per meter square. So can I write like this? So 100 into 1000 Newton per meter square, which means 10 to the power of 5 Newton per meter square. Here it is, we can write 10 square into 10 cube. It is nothing but it is in the form of a to the power of m into a to the power of n, simply a to the power of m plus n, law of indices, right? So 1 bar is equal to how many Newton per meter square? It is equal to 10 to the power of 5 Newton per meter square. This units conversion is very, very, very important. This units conversion is very, very important. So 1 kilopascal is equal to 1000 Newton per meter square. 1 bar is equal to 100 kPa, or 1 bar is also equal to 10 to the power of 5 Newton per meter square. Such kind of questions are very, very important for your EAMCET exams and also local EAMCET exam. So this unit conversion is very, very important. You are supposed to remember this value. So 1 bar is approximately equal to, not approximately, exactly equal to 10 to the power of 5 Newton per meter square. Now let us have a discussion on Pascal. Right? So Pascal's law states that, the pressure or intensity of pressure, both are same, my dear students. It states that pressure or intensity of pressure at a point, in a static fluid, is equal in all the direction, So here the important keyword is stationary or static. So for example, when a fluid is at rest, as I told you, when the fluid is in a glass without any disturbance, the intensity of pressure or pressure acting on the fluid is equal in all the directions. For example, if you take infinite direction, the intensity of pressure or force acting on the fluid particle is equal in all the directions. See, for example, if this is a container, if the container is filled with water, okay, if I take 3-dimensional system, if this is x direction, if this is y direction, and if this is z direction or z direction, the intensity of pressure in fx direction is equal to the intensity of pressure from fy direction and intensity of pressure in fz direction. The intensity of pressure in x direction is equal to intensity of pressure in y direction is equal to intensity of pressure in z direction, because forces acting in any direction is same. So if you are finding difficulty in this definition, you just try to remember this definition. So what is Pascal's law? Pascal's law states that the pressure or intensity of pressure, both are same, pressure or intensity of pressure at a point when fluid is at static or fluid is at rest or stationary, then the intensity of pressure is equal in all the direction. Whatever may be the direction, it is equal. So the pressure applied to any part of the enclosed fluid at rest is transmitted undiminished to every portion of the fluid and to the walls of vessel. If you consider a small fluid particle at a place of A units from the top, then if the intensity of pressure is same in all the direction, but the condition is the fluid should be in static. Fluid condition should be static. So what is the formula for intensity of pressure? Intensity of pressure is equal to, it's a ratio of force by area. Yes, right. So in a similar fashion, as I told you, the pressure is same in all the directions, whether it is x direction or whether it is a y direction, whether it is a z direction, whatever may be the direction, the intensity of pressure is same. This is one of the what you call elementary particle of a fluid. Okay, if a squeezed liquid comes with equal speed from the all the holes, okay, for that I am going to consider a small what you call this thing, a small cylinder which is filled with a juice or a liquid, So what I am going to do, I am going to make some holes at the different locations. I am going to make some holes at different locations. So I am going to make a hole here. Sorry, it's not working. Okay, it's not working, no problem. So I'm going to consider a small cylinder or small container which is filled with a juice or a liquid. If I make some holes at different locations, what happens? Water comes out, it gushes out, right? Whatever may be the place, the intensity of pressure is same from all the three directions, or the pressure is same from all the holes. So practically we can prove that Pascal's law is valid here. Okay, fine. Now let us do the verification with some example. Okay, now let us do some verification for this Pascal's law. So for that I took a container and I filled with water. I'm going to fill with water. So in this section, in this water, I'm going to consider a small elementary section. This elementary is nothing, small elementary section is nothing but some imaginary section. Okay, so which will be in the form of a right angle triangle. In general, it is a prism. Okay, so for this elementary section, A, B, C is the first section which is right angle at B, and D, E and F which is located at the back side of this elementary section. As I tell you, it is having the equal pressure in all the direction. Let the pressure in this direction be F1. Let the pressure be in this direction be Px. Let the pressure in this direction be Pz. Okay, so consider a small element in the interior of the fluid which is at rest. So this rest is very important. As I told you, fluid will be in the rest condition. The element AB, the element ABC and DEF is in the form of a right angled prism. So every part is considered at the same depth from the liquid surface, and therefore the effect of gravity is the same in all the directions or same in all these points. Okay, so for that, suppose the fluid pressure PA, PB and PC are going to act in the faces of BEFC, ADFC and ADEB respectively. Okay, so the force F1 is acting in the face of BCFD, and the pressure F3 is acting in the face of ADEB, and the force acting F2 on ADFC. So here F1, F2 and F3 are the forces acting on this elementary section, or the forces. In similar fashion, PA, PB and PC are the pressures acting on this elementary section. Let capitals A and suffix AB and AC are the area of this elementary section. Okay. FC is going to act on A, B, and FA is going to act on the face of BC, and FB is going to act on the AC. Okay, if you are going to resolve this FB component, we are going to get two components, that is FB sin theta and FB cos theta with an angle of 90 minus theta. So according to Newton's law of equilibrium, the two forces should be always equal in opposite direction. If FC is acting in horizontal direction, which component is to be act to balance it? So are we going to use FB sin theta or FB cos theta? See, if this force is acting in this direction, which component should act in the opposite direction? In general, we are going to use FB cos 90 minus theta 2. So FB cos 90 is nothing but sin theta. So in order to balance FB sin theta, it is going to balance by using FC. So this force is balanced by this force. In similar fashion, the vertical force which is acting, that is FA, is balanced by the component of FB sin 90 minus theta 2. So what is sin 90 minus theta 2? As everyone knows, that is FB cos theta 2. So this vertical force is balanced by this component, and this horizontal force is balanced by this FB cos theta, right? Which means that intensity of pressure is acting in all the direction is same when the fluid is at rest, condition. Now let us see some practical applications of this Pascal's law. So in general, whenever we take our cars for garage for what we call service or any maintenance, we use this hydraulic lift to lift the car. Have you ever seen this hydraulic lift? Yes. So even this hydraulic lift works on the principle of Pascal's law. Usually we see this hydraulic lift in car garages, as I told you. So but the basic application is Pascal's law itself. As you see here, F1 is a force that is acting at the small elementary section, that is A1. A1 is smaller area of the piston. A2 be the larger area of the piston. So F1 is a force acting on the smaller section or smaller piston. F2 is the force that is acting on the larger piston. So when we apply force on a smaller section, it is going to lift the load. From basic formula, intensity of load, what is the formula for intensity of pressure? P is equal to force by area, right? Or dP is equal to dF by dA, right? So in general, P1 is equal to force 1 divided by area 1 and P2 is equal to F2 divided by area 2, right? So in a similar fashion, if we equate the pressures, like in the equilibrium condition, F2 is equal to F1, intensity of pressure 1 at smaller section is equal to intensity of pressure at smaller section 2, right? Yes. So what is the formula for P1? F1 by A1 is equal to F2 by A2. Now we are going to find the F2, force applied on the larger piston. So F2 is equal to, if you cross multiply, F1 into A2 by A1. A2 by A1 is the shape factor or ratio of the areas. So this is a practical application of Pascal's law. In a similar fashion, have you ever observed how a moving car is stopped in fraction of seconds? Yes, even there we are going to use this Pascal's law. Even in working of this hydraulic brake, we use Pascal's law. See, F1 is a smaller force is applied on the smaller area, right? Here large force is applied on the larger area where your vehicle is going to stop, Even hydraulic brake works on the principle of Pascal's law. So here P is equal to force by area is constant. This is called as intensity of pressure. So my dear students, as P is directly proportional to force and P is inversely proportional to area, when area increases, pressure decreases. When area decreases, pressure increases. When force increases, pressure increases, as pressure is directly proportional to force. When force decreases, pressure also decreases. So here, as area 1 is less than area 2, force 1 is also less than force 2, as force is directly proportional to area. If we apply less force over a smaller area, we can produce a larger force over larger area. So the working principle of hydraulic brake is an application of Pascal law. So we are going to apply a smaller force on smaller area, which is going to create a huge impact by stopping a vehicle by applying a large force on larger area, right? So this is a practical application of Pascal's law. So this is an hydraulic jack, hydraulic lift, and this is a hydraulic jack where we use the application of Pascal's law. So now let us solve one small question on this Pascal's law. Okay, so according to Pascal's law, pressure transmitted in is same in the liquid, force transmitted is same in the liquid, acceleration transmitted is same in the liquid, temperature transmitted is same in the liquid. In general, in Pascal's law, as we know, intensity of pressure is force by area. So we only discuss about pressure and force. In addition to that, area. Do you have any concept of temperature here? No. So the temperature transmitted is same in the liquid? No, this is the wrong answer. Acceleration transmitted is same in the liquid. Do you have any any formula related with acceleration in pressure? No, even this is also wrong answer. Force transmitted is same in the liquid. Okay, now let us see, pressure transmitted is same in the liquid. So as we know, pressure is directly proportional to force and pressure is inversely proportional to area. So for example, if we go back to our previous case, the working principle of hydraulic lift or even in the working principle of hydraulic brake, when we apply smaller force, it is going to create impact of larger force. If we apply smaller pressure, it is going to create impact of larger pressure. So according to Pascal's law, the pressure transmitted is same in the liquid. The pressure is transmitted is same in the liquid. That is hydraulic brakes or hydraulic jack, working application of hydraulic jack. So for this question, according to Pascal's law, the pressure transmitted is same in the liquid. So before we wind up this session, today we have seen intensity of pressure or dP is equal to force acting per unit area, or intensity of pressure is equal to force by area, or force is equal to product of pressure into area. So the another definition for force is equal to product of force into area. Thank you. Do like, share and subscribe. Thank you.